Hello everyone, we are live again with the another session of Bootcamp. Today we are going to cover step function. Sazia, do you want to add anything?
Just that uh, it is being said that step functions are used for orchestration. And orchestration is basically, in the when you're playing music, the guy who's in control, he tells you who is going to play and who is not. So therefore, if you think of cloud computing as orchestra or the lambda functions as orchestra, step functions basically does orchestration. And let's see how Huma basically tells us about what is the theory behind it.
Okay, sir. As you already introduced, step function is said to do the orchestration of the app. It actually helps you in the smooth flow of your workflow. So far, we have seen quite straight sequential services using them and connecting them through event bus and other communication services. But this is not the case. We will be working in real business applications. Very soon, you will be needing something more complex than simple sequential tasks. Like you might need some tasks to work in parallel. Once they are done their parallel execution, only then you can move forward. You might need some kind of decision branching, that if the outcome of this task is true, do one thing, and if it's false, do the other. And what if any task fails? We need some kind of error handling. What about retries? And the very important thing we need to manage is rollbacks. What does rollback mean is, let's say I have to achieve a task, and that task is achieved, that functionality is achieved by 7 lambdas. For example, uh, these 7 lambdas will work together, only then I'll achieve my functionality. And somewhere between 5 to 6, that lambda fails. What would I do then? All I am left with is go back to the starting and do all the executions. So it turns out that there's nothing such thing like state management, so that I can keep the state of those functions which were actually successful and use them to move forward. So this is where step functions help a lot. All these functionalities can be achieved by doing all those functionalities manually, writing a lot of code, integrating so many services. But step function actually helps in orchestrating that all. It makes our job easy. Let me share a few pictures. Uh, hmm. uh, are you people seeing my screen?
Not yet. Yep.
Seen?
Yep.
Okay. So step functions actually help in managing state, keeping those memories, and you can have the flow of information within your application with all those services you are using. So all those functions working together, whether it's lambda functions or other services, actually combine and become a state machine. All those functionalities working together, flow and the flow of information going through each other's, they to come together become your state machine, and each functionality or AWS service becomes your state. And that collection of computational stages are your orchestration. So state transition is moving from one state to another. This is what we call state transition. Since it's within a state machine, I have to define what state my particular task is. If it's simple performing some computational work, it will call task. Uh, if it's doing some kind of branching on the base of previous task or input or output, it will call choice. If your task needs some kind of timeout delay, you can attach wait. And parallel is self-explanatory. If your task need to be done parallel, you can chain them in parallel. Mapping is simple plain JavaScript mapping. If the output of the previous task is an array, you can run mapping on them. And succeed will simply output that your task is succeeded and will end the task flow. The fail will do so. It will just label out that it's failed and it will end the flow of the work. Pass will simply pass the information from previous task to forward task. I just have few pics from AWS just for visual learners. This is how sequential task looks. Invoke a lambda function and once it's done, move ahead and do the other function. But what if you have to just pass your state and then you have to trigger other functionality? This is how branching looks, that if my operation is successful, do one thing. If it's not, do the other thing. And this is how parallel tasks look. Now, once the parallel execution is done, the output from all three can be the input for next function. And very soon you will be having any complex execution. You can use any combination of these states and design your own workflow. And last, there are two types of step functions, standard versus express. They are quite different. So in order to design your state machine, you have to go through this, that what actually is your requirement. Done, sir.
Varis, now it is your turn to basically explain to us in code. I think we can't hear you. You have to unmute your mic.
Yeah, can you hear me now?
Yes, my friend.
Yeah. Okay, so basically Homa gave us a very nice detailed introduction about step functions. So I'm just going to quickly go through a few things before starting the code. So I'm quickly going to go through the documentation. Okay, so if you read the first paragraph, it says that step functions is a serverless orchestration service that lets you combine AWS Lambda functions and other AWS services to build business critical applications. Through step functions graphical console, you see your application's workflow as a series of event-driven steps. So basically, this paragraph is saying that if you step function basically allows you to implement a workflow using Lambda functions, and also allows you to implement orchestration, as Zia discussed. So basically, if you want to implement a workflow that has a lot of different Lambda functions, and you require these Lambda functions to communicate with each other, and you also want a very good error handling, and you also want to specify a particular pattern or sequence in which you want to run these Lambda functions, then step functions is the service to go for. And then the second line is saying that you can actually graphically visualize your entire flow, the entire flow of your step function in the console that Homa just showed you. And I think that can be very useful to have like a bigger picture of your architecture or your step function. Like if you have like 10 or 15 Lambda functions, you can see all of them in their states, whether they have succeeded or they have failed. And then the next line says that step function is based on state machines. Now this is again very important, as Homa discussed, that step functions are basically state machines. And this means that they are very deterministic. So this means that at each and every instance, they have a state or they maintain a state. So it's very easy to determine their state at each and every instance. So they are very deterministic. Okay, so I think this topic can be quite confusing, and it's a very lengthy topic. It's not easy. It's not only difficult to understand, but it's also difficult to explain. So I've actually made a simple example so that you guys can like have a better understanding, like have a basic understanding, like how does step functions work before going through the code. So basically, you can see that the first thing you will notice that we have a few Lambda functions. So this entire thing is your step function, and you can see that we have few Lambda functions inside it. So assume that this entire thing, everything that is made on this page is a part of the step function. And so right now you can see that we have 4 different Lambda functions inside this step function, right? And the second thing that you need to understand is that step functions work in steps, as the name suggests. So in this example, we have 3 different steps. This is the first step. In the first step, we just have 1 Lambda function. In the second step, we again have just 1 Lambda function. And in the third step, we have this entire thing. We have 2 Lambda functions and we have a branch, right? So step functions basically execute sequentially, like in steps. So this would execute first because this is the first step, and then this step would execute, and then this step would execute. So this is how step functions work. Now let's go through all the steps line by line, step by step. So this is where your step function is starting. So let's say I started my step function over here. Now, when you start a step function, you can give an input to it. but it's totally optional. But if you want to, you can give an input. So let's say that I started my step function and I gave an input, and that input can be anything. So let's assume that I gave it an input. This is my input as its input. So the input that I gave to the step function would become the input of my first step, right? Because so whatever you, so this is not, so be mindful that I did not pass this to the lambda function directly. I passed this input to the step function, but because my first step has lambda function, that would be passed to the input of my first step, and then the first step is lambda function, so this would be passed to the input of the lambda function, right? And what do I mean by the input of the lambda function? I mean the event. So this thing would be accessible in the event of this lambda function. So this lambda function would take the event, extract this information, do some processing, and it would return something. Now that return value becomes the output of the step. Now the input of this step was coming from here, and the output of this step would be the return value of the lambda function. And the return value of the previous step becomes the input of the next step. So the output value of this step becomes the input of this step. In other words, whatever is returned by this lambda function goes in the input or in the event of this lambda function. So let's say that this lambda function returned this JSON object. So this JSON object would then be available in the input of the next step, and that means in the input in the event of this lambda function. So now this lambda function would have access to this object that was returned by the previous step. It would extract that object, do some processing, and then return something. Now that becomes the input for the next step. So you can see the pattern over here. The output of the previous step becomes the input of the next step. This is a very important concept in step functions. So now you can see this step is a bit different. Now we're saying that before passing the return value from the previous step, we want to apply a condition. So let's say that this function returned a Boolean value. Now we're saying that we first want to check if it's true, then we want to take this path and run this lambda function. So if it's true, then the output of this lambda function would go into the input of this lambda function. But if it's false, then the output would go to this lambda function. So we can also
Varis, we have lost you. I think you will need to reconnect.
Let me call him. He might be not listening.
In step functions, right? So basically, the bottom line cases. So this is the first use case in which they are just making a chain of step functions, just like I showed you over here, what we were doing over here. So basically, this lambda function would take an input, it would do some processing, it would return something, that would be passed to this lambda function, it would return something, then this the value returned by this lambda function would be. Hello.
हाँ, आपका कनेक्शन ड्रॉप हुआ था थोड़ी देर के लिए और मिक्स हो गया.
Can you guys hear me now?
Yes, we can hear you now.
Yes.
Okay. So where did I drop off?
It's okay. Just start with the use cases.
Okay. So they have actually given us some use cases in the documentation. So this is the first use case in which they have chained some lambda functions in a sequential order. This is exactly the same that we did over here, and like in these first two lambda functions. So this lambda function would get some in.
Varis, you are again stuck. I think you will have to reconnect.
Trying him again.
You can add some condition over here, and based on that condition, you can
Varis,
take either one.
Please disconnect and connect again. Again, we lost you.
Oh, okay. Let me disconnect.
I think the issue.
Yes, sir. You were saying something?
Yes, I was saying that I think the issue with Varis' computer is that most of the time he is doing heavy workload. So therefore, once he starts the class, his RAM is already consumed. There must be some leak in some software memory, or he is opening too many what do you call applications at the same time. That's the problem. So what he need to do is, and at the start of every class, he has to reboot. As you know, in software, there is no problem which cannot be solved by rebooting the application.
There is always a final last resort as rebooting, or sometimes we use it as a first resort.
I had a student once who told me that he was asking me, "Sir, I have a bug in my code." I said, "What is your bug?" He said, "My bug is that every time at 5 o'clock in the morning, my software doesn't run." So we are faced with the same situation.
Can you hear me, guys?
Yes, Varis, from now on,
Yes.
every time you start a class, please reboot your system before starting.
Okay. So this was the first use case in which we were chaining the Lambda functions together. Now this is the second use case in which we are branching. This is the same thing that I showed you in our example over here. You can actually apply a condition, and then based on that condition, you can take either one of these routes. And another use case is error handling. So in this case, it's saying that, let's say that this Lambda function is failing. So it's saying I'm going to try like 10 times. And even if it fails the 10th time, then I'm going to run another Lambda function. So in the retry, you're going to retry the same Lambda function, and in the catch, you're going to do something else if even then it keeps on failing. And then you can, in the fourth use case, you can actually have a human in the loop or a service in the loop that can actually take or send some data to the step function or a Lambda function in the step function. And then this is parallel processing, in which you can actually run many different Lambda functions or actions in parallel or simultaneously. So let's say you can actually run 5 or 6 or 7 Lambda functions simultaneously together. And this is dynamic parallelism. Now this is very, very complex. So one Lambda function is invoking 3 other Lambda functions simultaneously, and then each one of those functions are invoking another function, and those functions are invoking. So this is a very, very complex example. So you can actually imagine that the kind of stuff you can make with step functions.
Excuse me. Excuse me, sir.
So yeah, so let's start with the code. So if I go to the repository, we have like 6 different steps. It's a very, very lengthy topic. So I may skip some of them because some of them are repeating. Like we have 2 steps for choice. So I might just explain one of them. If we, I'm not sure how much time would it take. Anyways, let's start with the first step. So this step is very, very similar to this thing over here, only this part over here. So we have 2 Lambda functions in this example that are connected together in a step function, exactly in the similar manner, exactly in the same manner, right? So let's see what's happening. So first of all, we have defined a DynamoDB table, and we will use this in one of the Lambda functions. That's why we have defined it over here. And then we have made a Lambda function, right? So this Lambda function would actually be using DynamoDB inside it. I'll tell you why. And then we have actually given access of the DynamoDB table to the Lambda function, and then we are passing the name of the DynamoDB table in this Lambda function. So up till now, we have just created a DynamoDB table and a Lambda function. And now let's go inside this Lambda function. So basically, this Lambda function is going to be our first step in the step function. So I'm talking about this Lambda function. It's going to be executed first. So let's go inside the code of this Lambda function. So it's a very simple code. We're doing nothing. We're just adding one item in the DynamoDB table. I think we have done this hundreds of times, but let me just quickly repeat it. So we are destructuring DynamoDB from this library, and then we're creating an instance. And then this instance has a function put item, And what are we putting? We're putting this item over here. The ID comes from the date, so the current date in milliseconds, and messages new entry edit. And we also have to pass the name of the table, and that's it. It's a very, very simple code. So here we're adding a simple item in the DynamoDB table, right? Now, the important thing is that if this item is added successfully to the DynamoDB table, then we are returning this object that has a path operation successful. That says true. If it was successfully added, the item was successfully added in the DynamoDB table. But if something went wrong, then we are returning operation successful false. Now this is very important. Why? Because this output would be used as an input by our second Lambda function, right? So this Lambda function is returning operation successful. It's true if everything goes right. If something goes wrong, then it's false. Now let's go back to our stack. So this was our first Lambda function. Now here we have defined our second Lambda function, and let's go inside it and let's see what's happening inside it. So this Lambda function is doing nothing. It is just taking the output of the previous Lambda function, which would be its input. So as I told you before, the output of the previous Lambda function becomes the input of the next Lambda function. And by input, I mean that data is accessible in the event. So you can see it's expecting operation successful in its event, which was returned by the previous Lambda function. So we're just checking if it's true, then we are going to log this. If it's false, then we're going to log this. That's it. So up till now, we have only defined the Lambda function. We have not created a step function yet. So now let's see how to create a step function. Let me just open Notepad. So there are three steps there are three steps to make a step function. In the first step, you create your steps. The second step, you create a chain to define the sequence of your steps. Right. So in the first step, you define your steps. Like I would define, this is a step. This is right now they're Lambda functions. They're not steps, right? I just created Lambda functions. I have to convert them into steps, and then I'm going to define the sequence. Like I would tell the step function that I need to run this Lambda function first, and after that I want to run this Lambda function. So in the second step, you define your sequence in a chain, and in the third step, you refer your chain to the state machine or Lambda or step function. Right. You basically create a state machine and then you refer your sequence in the state machine. So let's look at the first step now. We have created the Lambda functions. Now let's create steps out of them. So here we go. This is how you create a step. So to create a step, you write step function tasks dot Lambda invoke. Now I told you before that these steps can have different actions. Right now we are only seeing Lambda functions, so that's why we're using Lambda invoke. So this basically tells step function that the step has a Lambda function inside it. And this is where you define the name of the step. This can be anything, and then inside and then in the parameters you refer the Lambda function. So basically I'm saying I'm referring this Lambda function that was adding the data in the DynamoDB table. So basically I've created a step for that Lambda function. Now I need to create another step for the second Lambda function. That's why I created a second step in a very similar way, but I have referenced the other one in the Lambda function. So I have created steps for both of my Lambda functions now. Now we're done with the first step. Now the second step is to define the sequence. Now right now I've just created the steps. The step function doesn't know which one to execute first and which one to execute second. So to do that, you create a chain. To create a chain, you write step functions dot chain dot start. So here you have to write which step do you want to start with. So in this step, in the start, I'm referring this step. I'm saying that I want to start my step function with this step, and the next step should be this one. So I've referenced both of my steps in the chain. Now step function exactly knows that in which order do I need to run them. And then you have to create your state machine. As I told you, in the third step, you create your state machine and refer your chain in it. So I've created my state machine, and then I have referenced my chain in it, and that's it. That's how you create a step function. So let's deploy it. the console of step functions has some very, very interesting features. Okay, so what basically would happen over here is that this, first of all, this lambda function would get invoked. This would try to add item in the DynamoDB table, and if it successfully adds it, then it will run operation successful true, right? And then this step would end. Then the second step would start, in which we are invoking this lambda function, and the, as I told you before, the output of the first step becomes the input of the next step. So this step would have the output of so this lambda function would receive the output from the previous lambda function.
Varis, the payload word is keyword.
Yeah, I'm going to come to that. I'm going to come to that later.
Okay.
Yeah. But you can see this thing over here is written over here. I'm going to come to payload in a minute. So so to start your execution, you can actually click over here. And then, so I told you that you can actually provide input to the step function if you want to. It's completely optional. We are not exactly using the event in our first step, so we don't really care about the input. I'm just going to leave it. So you can see it has actually given you a very good graphical representation of your step function. It's showing you have 2 steps, and you can name them anything you want to. And then it's also showing you the status. So it's saying both of them have succeeded. Now it also gives you some logs. Now these logs are very, very interesting. So let's go through them. Okay, so let's go to the output log of our first step. Right. So you can see our first step, and when this got executed, this returned something. Everything that the step returns goes in the output path. The rest of the stuff comes from the step function. It's just metadata data, but the thing that you return from your step comes in the output path. So you can see in the output path we have some extra stuff that is added by the step function itself, but in the payload path we have what was returned by the lambda function. So whatever lambda function returns is automatically goes inside the output payload, right? So that's why I have written event.payload.operation successful.
But Varis, there's no output.
Yeah. Wait, let me show you. So basically this was the output coming from the previous lambda function. And okay, now this exact thing goes as an input to the next lambda function. So you can see this exact thing is copied over here, and this is what is coming in the event. So the input is not coming in the event. This entire thing is coming in the event. That's why we wrote payload.operation successful. Did you get that, sir?
Yes.
Yeah. So this entire output thing.
Can you increase the font a bit?
Oh yeah. Yeah. So this entire thing goes in the event of the second lambda function. Okay. Now there's one more thing that I need to discuss over here. Let's say that, so you can see we have some extra information as well over here. We don't really care about this, and there might be many other paths over here, many other keys over here that we don't really care about. So you can also filter your input. So I can also say that I only want this thing inside my event. I don't want this entire thing, but I only want this thing inside my event. You can do that as well, and you can do that by. So when you were defining your steps, you can do that by adding this parameter input path. So this is saying that by default, I'm getting this entire thing in my input in the event of my Lambda function. But if I say I only want payload in the event of my Lambda function, I can do that as well. So if I write this thing over here, this would mean that only this thing would come in the event of my Lambda function. And if I do that, then I would have to go back into the Lambda function and remove this. Why? Because I have filtered my input and I'm only getting this in the event. So you can do that as well. And you can also have an output path. So this actually filters out the output of the step. So this was our first example. Let's move on to the next example. So up till now, we have only discussed Lambda functions as steps or states. Now in the next step, we're not going to see any Lambda function. We're going to see some other stuff. Okay. So in this step, we're still using the same architecture. We will still have two steps connected like this, but instead of Lambda function, we would have something else. So here we have defined our first step. We have not defined, yeah, okay. So when we were defining Lambda function, first we had to actually initialize the Lambda function, and then we had to make it a step. But this is called a pass step. If you just create it, then it becomes your step automatically. You don't have to separately create a step for it, like you did in the Lambda function. So if you just write this thing, then this entire thing becomes a step. You can directly pass it into your chain. So, but what is it? So basically, if I remove these parameters, pass step is nothing but it just takes your input and pass it to your output as it is if I remove all the parameters. But it is more or less useless because there's no use of it. But you can also add some static data before passing it to the output. Like if I take an input, I can add some data to it and then pass it to my output. But this data has to be static, or it should be coming from the previous step, because unlike Lambda function, it cannot do any processing. So if I can open Notepad, so let's say that the input that it received was something like data, right? Now, if I remove all the parameters, then the output would be the same if I remove everything else, if I'm not adding any data. Right. But now, in this case, we're adding some data, though. Let me show you how does it add data. So basically, first of all, it copies the input to its output, and then it adds data. So what are we adding? We are saying, first of all, create a path named sub object. And in that path, I want to add this object. This is what we are saying. Basically, this path step is outputting this. Let's say it got this in the input, it would output something like this. So this would be like your input, and it would also add some additional data to it. You can do this. So this was your, so this is the first step in this will be the first step in our step function. Now let's look at the next step. So this output would be the input of the next step, right? So the next step is our wait step. Now wait step is also very similar to pass step. It does nothing. It just takes its input and passes it to the output, but it waits for a few seconds before passing it to the output. And you can define that delay over here. So let's say that the input wait step. Is going to be the same as the output of the previous step. And the output is going to be the same as well. Why? Because it doesn't do anything to the state. So the output is going to be the same, but it's going to wait for a few seconds or minutes before publishing the output. Now you can define that time in this parameter, in the time parameter. Now I think you can also write a static value, but in this case, what we're saying is that we're saying that we want to wait for certain for certain amount of seconds, and how many seconds we want to get that value from the input that is being received by this wait step. So if I go into the input, you can see we have a sub object that came from the previous step, and in that sub object we are saying we want to go to the trigger time, and the value of trigger time is 2. So it's gonna wait for 2 seconds before giving out its output. So it's gonna wait for 2 seconds over here. And that's it. This is the first step, and the wait step is the second step, and that's it. Let me just quickly deploy it, and let's see. Let's have a look at it in the console. And then just like before, we have first added a pass step in the chain, and then the wait step in the chain, and then we have referenced our chain in the state machine. Now it might have a few more parameters that you can see in the documentation. I think this also has input path, and it might also have.
What is the maximum time it can wait?
I'm not sure.
Mhm.
I had like 100 over here. I'm not sure. I think it can wait for as long as you want it to.
Mhm.
10 days?
But I was reading that you can also specify a time so that it can run on a particular time as well. Mhm.
Or maybe it has a parameter that allows you to do that.
Mhm. Yes.
So we can start execution. Whatever I write over here would go over here in the input of the pass step. So I can just leave it to default. So you can see it's waiting. It's in progress. So if we go to the logs, so you can see in the start, the input, this is the input that we provided. This goes to the pass state. See in the input, we have the same thing. In the exit, so you can see in the output, we added this new path that I told you about. And in the wait state, the input is same, exactly the same as the output from the previous step. And we can also check the amount of time it waited. So it waited, you can see exactly 2 seconds, 55 and 57. So yeah, this was our example 2. Let's move on to the next example. Okay, so this is where we will discuss the choice step. So up till now we have discussed the lambda step, then pass step or state, and then wait state. Now we're going to discuss choice step that will allow us to do something like this. Something like this. We will be able to add that. So I think our architecture is something. Wait, my mouse stopped working. Okay, our architecture would be something like this in this example. So okay. So first of all, we have created a DynamoDB table. Again, I think we're using this exactly the same lambda function that we use in the first example. So we have created a DynamoDB table, then we created a lambda function, then we gave access of the DynamoDB table to the lambda function, and in the lambda function we're doing the same thing. We are putting an item in the DynamoDB table, and then we're returning the same thing: operation successful, true if it was successful; if something went wrong, then false. So this is going to be our first step, this lambda function in our step function, and we have also created the step for it. So we have referenced our lambda function over here. We're saying we want to create a step for this lambda function, right? Now there are a few new things over here. So I'm going to come to them in a minute. So if I go to directly to the chain, you can see first we're executing the lambda function that I just talked about. So this lambda function is returning operation successful, true or false, and then we are running something called choice. Okay, so let's come to the choice first. A choice set basically allows you to do something like this. So you can actually the input that it receives, you can put a condition on that input, and based on the condition you can go to either one of these branches or some more branches as well. You can have either 1, 2, 3, 4, 5, as many branches as you want. So you can see first of all I've initialized my choice step, and then in the choice step to add branches you can write when. So basically,
can you please zoom in
oh okay. So this is where I'm creating one branch, and this is where I'm creating second branch. So I'm saying when should it go into this branch? When the input that it receives, so it will receive the input from the lambda function. The output of the lambda function would be the input of this step, and the lambda function was giving out operation successful. That was either true or false. So I'm saying that the input that we have received, check that if it's true. I'm telling it that it's Boolean, and I'm asking it if it's true, then you should run this thing. I'm going to come to it later at what it is. But if it's true, then you can run this thing. Now this can be a lambda function or some other step, or it can be anything. But if that value is false, then run this thing. So that is our architecture. We ran the first step was a lambda function that returns something, and that return value is being checked in another choice step, and based on that value, the choice step can take two routes. So the important thing to understand over here is that we have not defined these two routes. Now these two things are also steps, but we have not defined them in the chain. Why? Because choice is responsible for invoking them or running them. We have only mentioned choice in our chain, and choice would be invoking the routes or the paths or the branches. So let's see what are these success and job failed. So if the output of the lambda function was true, then run the success step. Now let's see what it is. So this is our success step, just one line of code. Now this basically what it does is basically whenever we run this thing, it terminates the entire step function with a success status. And the other thing that we're running is false. Whenever if the lambda function failed to enter an entry in the DynamoDB table, then run this thing. And this thing is similar to success, but it just terminates the entire step function with a status of false. So this also terminates the execution of step function. This also terminates the execution of step function, but this terminates with a status of success. This terminates it with a status of false. Failure. And you can also write cause and error in this. I think these are optional, but you can write if you want to. So basically, the status of this step function can be important for other services that are like listening to it, or the events generated by the step functions would have the status of it. So the other services might want to know that if the step function succeeded or failed. So if I can just quickly repeat the architecture. First of all, we're going to run the lambda function that would return either true or false. Now, if it's true, then we would, then the choice would run this thing, and this would terminate our step function with a status of success. And if it falls, we're gonna terminate the step function with the status of failure. Let's quickly deploy it. So even if you don't add these two states, if your lambda, if your step function, if nothing goes wrong in the step function, like we saw in the previous examples, everything was green, even then it terminates with a successful, what do you call it, successful status. But if you like manually want to terminate it with a successful status, then you have to run this. Otherwise, when your if your step function is ending naturally, then obviously it will terminate with a successful status. And same goes for the failure state. If naturally something goes wrong in the step function, like if one of your lambda function fails, then naturally it would terminate with a failure status. But if you want to do it manually, then you have to run this thing. Now, our next step is also about this choice state, and it's a bit more complex example. So I'm not going to go through it because I think we will run out of time. I still have to cover some other important stuff. So you guys can actually go through it in your own time. It's a very interesting example. Okay, it's done. Oh, it's not done. Okay. So I'm going to start the execution. I don't really care about the input because I'm not using it. I'm going to leave it. So you can see it has a very interesting flow diagram. First, we run the lambda function. Then this is our choice state. It checks if the value was true. Then it runs this path. If it was false, then it would have run this path, and this would have turned red, stating that our step function failed. So if I go to the logs, so this is the output of your lambda function. Operation successful, true. And this is where we entered the choice state. Here we checked if this was true or false. And because it was true, we ran this succeed state. Otherwise, we would have ran the fail state. So this was our step 2. Now I'm skipping this step 3. I'm going directly to step 4. Okay. Now, in this example, we are going to have a look at the parallel step. So basically, parallel step allows you to run many different actions, lambda functions, or pass states, or wait states simultaneously, like at the same time. So I'm gonna skip everything, and first of all, I'm gonna go to the chain. So in the chain, you can see we only have one step, that is our parallel step. Now let's have a look at it. So to create a parallel step, you can just write step functions or parallel, and you can give it a name. Now to add the actions, you can write parallel.branch, and then what you want to invoke in this branch, you can write it over here. So this can be a lambda function, this can be a pass state, this can be a wait state. So all these branches would be executing simultaneously. So right now we have 3 branches. Now the important thing to understand over here is that we only have one step in this example. Now, even though it's executing lambda functions or pass states, those would not be separate steps. They would be a part of the same step. So that's why we only have one step over here. So in this example, we are saying we are running 3 things in parallel. Now let's have a look at what are these 3 things. So if I go up, you can see I have defined 3 pass states. This is, so I would not call them steps in this example. I would call them branches. So these are 3 pass branches. So, and let me just quickly recall that pass branches do nothing. They just take the input. They can add some static data to the input and then pass it to the output. So the first branch is basically taking some input, then adding this thing and giving it and outputting it. The second one is doing the same as well, but instead of parallel branch 1, it's saying parallel branch 2. And the third one is doing the same thing, but it's outputting parallel branch 3. So this would be the output. So input plus this extra thing that it adds to the output. So our parallel step would be running all 3 branches simultaneously, and the output of this step would be the combined output of all 3 branches. So the output of this thing would be this, output of this thing would be this, and the output of the third branch would be this. But these are their individual outputs. The output of the parallel step that is running all of them together would combine the outputs, and that would be the output of our parallel state. So the output of the parallel state would have all these outputs combined, this, and this. So let's have a look at it. So let's start it. So you can see all the branches were executed simultaneously at the same time, not sequentially like we were doing before. And let's have a look at the logs. So let's have a look at the state exited. So you can see the output of the parallel branch is the combined output of all 3 branches. So yep. So the output is all 3 branches. The output is the output of all 3 branches combined. So if you want to run, so I've actually used pass steps over here. You can actually run lambda functions to do something more useful. If you want to do, if you want to run a few lambda functions simultaneously, you can do that using this parallel step. Now let's move on to the next step. Now this is our last example. So we still have one more example, but that is not doing anything important. It's just invoking an event, and then that event invokes the step function. I think we have seen that a lot of times. So So in this example, we're going to be discussing the pass step. So in the previous example, we saw the parallel step that runs many tasks simultaneously. In this step, we will see the map step that works very similarly to the map function in JavaScript. So first, let's go directly to the chain so that it's easy for us to follow. So in the chain, we're saying that our first step is this initial state. Now let's have a look at it. What is it? This initial state is a pass step. So let me just note that. It would have some input. Then over here, what we're doing is we're saying we want to take our input and we want to add a new path in it. That would be array output. And in that path, I want to add this array. This is what is our first step returning. Now this would go to the input of the second step. Now let's have a look at our second step. And our second step is the map step that is defined over here. So basically, in map step actually basically expects an array because it uses an array, and for every value of array, it can run an action like a lambda function or some other state. So let me repeat this: map state always expects an array, so that for each value of array, it can run a lambda function or some other action like pass step. So this map step would receive this output. So this value, which was the output of the previous step. So input map step will receive this in its input. So so you can see in the parameters of the map step, you're saying here in this parameter, you have to define the location of the array, or you have to define. I think you can also define the array manually, like you can write an array over here, or you can fetch an array from the input that it received. And we know that the input that it received had an array in it that was sent to it by the previous step. And where is that array? That array is at this path, array output. So we're saying get that array from the array output, right? And then iterate over that array, and for each iteration, run this thing. And what is this thing? We have defined another pass step over here that is doing nothing. It is just taking the input and passing it as it is to the output. We are not adding any data to it. So this is basically our this is how you actually implement map step. Let me just quickly repeat it. So our first step was a pass step that added an array in the state, and then it passed that array to the next step, which was our map step. The map step took that array, and for each value of that array, it ran this thing. What is this thing? This thing is another pass step that actually does nothing. It just takes input and passes it to output. But in a real life application, you would actually be running a lambda function or something more useful over here. And how this actually works is that first of all, in the first iteration, this would go into the input of this thing. Then in the second iteration, this would go into the input of this thing. And then in the third iteration, this would go into the input of this thing. So each value of the array would go into the input on each iteration.
So Waris, basically it means that we started off with a sequence with a known number of steps. Here because it is an iteration, it is unknown number of steps. That's the difference between the first one and the last one.
Yeah, I mean you can know the number of steps by the length of the array.
But it's dynamic. You can change
the
number of steps.
Yeah, that's true.
Mhm.
Yeah. So let me quickly deploy it. I've made very simple examples, but you can use these examples and use these concepts to make something very complex.
It's just a very comprehensive solution.
Yeah.
And another good thing is they have created everything as a separate entity. The choice is a separate, step is a separate, and you can just combine them like a puzzle to create an orchestration.
So you can see it mapped 3 times because our array had 3 elements in it. So this step gave an array to the mapping step, and mapping step ran another pass step for each value of that array. You can also have a look at the logs. So pass state entered, pass state exited. So it gave an array in its output that would be received in the input of the map state. You can see in the input we're receiving the array. So you can see it's saying the array has 3 elements in it, so I'm going to run 3 times. So for index 0, 1, 2, so it's basically it's running the simple pass step that takes input and passes it to output. So whatever we're receiving in the input, we're giving it out as an output. So these are all 3 steps, and then it succeeded. But you can see the output is the combined is again an array, and that array is the output from each iteration. So this is the output from first iteration, this is the output from second iteration, this is the output from third iteration. Now I'm not exactly sure. I think this is the case. So the output of each iteration would be combined into an array, and that would be the output of your map state. And that's it. Yeah. I think we're done.
Okay, Waris, I have a question before we complete our class.
Yeah.
To you, Huma, and Zeeshan, and to, of course, all the students. We have 2 options if you are doing a business application.
Yeah.
There is a sequence. Usually in business processes, it's a sequence of steps or conditions or iterations, as you mentioned. Now we have 2 choices when you are implementing a business solution. Business process. Actually, business solution is a very broad term. Business process. One is the event bridge, and the other one is the step function. You can achieve the same thing with both of them. For example, if you want to receive an order processing, let's see, you receive an order, you try to get the payment from a payment processor. If the payment processor gives you the money, you basically ship the product to the customer. To receive the order, store it. Number 2, get payment for it. Number 3, ship the item. If, of course, you receive the payment. If you don't receive the payment, tell the customer that the order has not been processed because we did not receive the payment. Which one will you apply and why? Actually, the why is more important. Event bridge or because we are now getting into advanced stages of this class. Once we go beyond, after a certain point, we want to produce architects who can think, look at the problem and think about it, what kind of technical solution they will apply. So what do you think? Any takers for this question? Yes, Zeeshan.
So basically, the advantage of a step function is you have a system of rollback, so that if at any point in time a particular step of a function breaks or there is a failure, so you can roll back everything. Another advantages or disadvantages, basically the way you are going to use the event bridge is if you want to integrate different services, or you want to send out event at the different location or a different account on different services. For step function, it's basically you are diversing or traveling your logic into same account or same business logic. So in case of the one we have discussed, the if you receive an order, then you have to process the payment, and then you have to send the invoices, and then you have to uh, do these things. I would be going for with the step function, because uh, because it gives me control over orchestration, that if I want to do all these steps in a parallel, and then I want to see the result, and then I want to send that result to customer, or wanted to update something to the customer. And if there is some failure, so I can identify that and I can roll back to complete a step with the step function. I do not have a such power in event bridge.
Okay. Varis, you have, or Rahman, do you have any views?
I was going to say the same thing because of that rollback policy, because of so many built-in advantages of try, catch, and state management. I was going to say that yes, step function is a better option. Plus, you can integrate event bridge within step function or not. I think you
Of
can
course,
use it.
of course,
Then,
you can have an event which starts a step function.
so I guess step function would be a rather better option.
Mm-hmm. Varis, any views? You are in deep thought, or your video is stuck? in,
Looks like a deep thought, but it's
I
good
think
to be
it's,
considered as a deep thought. Good
I
to be
think
considered as a deep thought.
uh, well, I think his video is stuck. The point is,
Yeah.
everything has a upside and downside. In engineering solutions, Varis, do you have any comments on this issue? I think she still can't hear us. The
Varis,
point
can you
is,
hear us?
Varis, can you hear us?
Yeah, I can hear you. So what are you
Okay.
asking?
Could you, Zeeshan, ask him this question again? Maybe he didn't get it.
Have you heard the question, Varis? I guess he's stuck again.
Okay, because in order to save time, we will go forward with it and just complete the class. The issue is,
Sure.
everything in engineering, when you try to solve a problem, it has pros and cons. There's no perfect solution. As you mentioned, you had mentioned till now the pros of using a step function. What is of course, obvious is it's easier to debug because all the logic is at the same place. If we are doing the same thing with the event bridge, everything will be scattered and we will not know, very difficult to debug. In here, all the logic will be at the same place. You can know and go and debug that seriously at single place in a step function. Zeeshan, is it? Did I? But there is a one problem with step
Yes.
functions: tight coupling.
Yes.
For example, we wanted to accept the order. Whenever the payment is received, we want another step in which we are sending a sales manager a well done message. We'll have to add the step and debug everything again. In an event bridge, what you'll have to do is just listen to event and add sending that email, and that's it. So in an event bridge, the coupling is not tight. You can make changes, but the downside of
Step function.
yes, but the downside of event bridge is that's very difficult to debug. Event bridge are not tightly coupled. It's loosely coupled. You can make changes. You can add steps without touching anything and without even debugging the other code. But in a step function, if you make changes, you will have to debug. But the good thing is you can easily debug because all the information is at the same place, and you can show somebody all the steps. A business manager who is not a programmer, he will understand. Imagine telling somebody who is not a programmer about event bridge that first we go to this point, we fire an event, then we go this. But there's pros and cons to both of them. What I'll do is, because an order thing is more or less fixed, I will go with step functions with the order thing. But if it is something which is flexible and can change, I will go with the event bridge so that if I want to make changes, I don't have to debug the whole thing again and again. Any last thoughts, Zeeshan?
Yeah, you are right. If we are going to integrate multiple services, then it would be better to go with the event. But the scenario we have discussed might be a better solution with the step function. But again, that's the what you say, pros and cons of every system, and you have to decide once, and then you have to if it's a big system, then you have to live with it for a particular period of time.
Another thing is, it is not important what solution, of course, it is important what solution you select. Actually, the more important thing is what logic did you use? Why you are making a particular choice? You should always be ready to defend your choices. That why somebody is very logical. You ask you, why did you use step function? I say, oh, because I didn't know any better. That's not a very good answer. He said, I thought about it. I maybe I should have used event bridge. I thought about it, and because of these reasons, I did not use event bridge. I used step function. Thank you, everybody. Bye bye. See you in the next class.
Okay, bye everyone.